Okay, welcome to the October edition of Ask the Experts. Today I have my colleague Stefan Wallin with me, and we're going to be talking about networking, specifically ISA-95 and segmented networks. If you have any questions, I do hope that you have a lot of questions. Please post them in the chat and we'll bring them up during the call. So welcome, Stefan. I'm going to give it to you to start this off.
Thank you, Fredrik. Happy to be here. So the agenda for today is I'm going to start with a little bit of introduction to ISA-95 and Purdue, those terms, what they mean in OT networks and how they are used. We will then zoom in a little bit to, I have to say, one of the interpretations which has to do with network segmentation and what that means in OT networks, challenges, opportunities, and how to overcome some technical hurdles to actually do orchestration in those kind of networks. Then a quick overview of the proxy functionality we have within Avassa to make it through those layers. And then Fredrik's going to take over and do a demo where we show the capabilities and wrap up with a Q&A session. So let me start a bit with the introduction on ISA-95 segmentation. And I actually put that into quotes for a reason. I'll come back to that. So I would say ISA-95 is used as a very generic terms these days to a couple of things. Let's look to the left in this slide. So most of you, I guess, have seen these layers. So at layer 0, we have the physical things. Layer 1, we have the controllers, the PLCs. Layer 2, SCADAs, etc. So these are our logical layers where we put different kinds of things in OT. So when we take a piece of software, we can say, does this relate to layer 3 or layer 1? Also, what's very important here is that if you look at sort of the production order, a production order goes from north to south. Another characteristic here is that the requirements on real time is very different. So I mean, in layer 1, we have real-time requirements, while we don't have that in layer 4. So far, this is more of a logical grouping of things in the OT network, and that's actually where things started in what was called the Purdue model. That's a model from the Purdue University. They looked at how could OT and IT be integrated, and they came up with this layering model, and nothing in that model had to do with network segmenting or security or so. It was a pure logical grouping of things in OT. Later on, maybe a more famous term than the ISA-95 standard took this logical model into sort of a full-fledged standard where they looked at data models in each layer, where they looked at functional flows in each model layer. But still, there was no security requirements, although we sort of erroneously these days talk about ISA-95 and network segmenting. There was nothing about that in ISA-95. That was about data models and logical flows. Then after that, now there is a ISA-99, which is a cybersecurity standard, maybe more known as 62443. That standard introduces network zones and conduits, meaning each layer could be a network segment on its own, and the communication between each layer should be controlled. So that's where we're going to focus today. So starting with the sort of logical things like Purdue and ISA-95, we see many customers we talk to, they use that more for a logical grouping of things. They use that for how to name things, how to put labels in our system. But some of our customers, they go all the way to the more sort of strict security interpretation according to ISA-99, where you have rules saying that communication can only go from a lower layer to an upper layer. So it's only from south to north, and it can only jump one layer. And why is that? Well, the whole idea is for security reasons. You want to protect your operational, the production of things. I mean, it can be any very important things that need to run, and you don't want to have security threats impacting that one. So it's primarily for security and control the systems from external networks. So that's the sort of strict network segmenting interpretation.
Can I ask, can you compare and contrast this to like classical, as old networking guys, like a private network with a DMC, for example?
Yeah, that's a good question. And honestly speaking, if you take just two layers of this model, you would put a DMC between the two layers. I would say a classical DMC in a private network is actually one of the diodes here between the layers. And you need that, and then you need to sort of take it layer by layer because in this you have multiple layers. In a typical enterprise security environment, you have sort of one network only that you protect. Also, another important thing here is it's unidirectional, whereas in those kind of environments, it's mostly bidirectional. But
True.
but that sort of IT security thing, you need to drop on this layer. That's what you do most of these days to make this sort of restriction happen.
Got it. So I mean, this is obviously a more complex network setup than just having a flat network for all these layers. What would you say? What are the main challenges, and maybe also the upsides, the possibilities that come with doing this?
Yeah. So if you take the upside, the argumentation is that you actually have a more fine-grained protection. You protect your sort of the segment where you have your PLCs. Those are totally protected from the rest of
Mm,
the network where you have your SCADA system. So it's more fine-grained. If you have sort of a vulnerability in one network, you don't have it in the others. Whereas you have a flat thing, it's sort of all or nothing. So
yeah.
it's more fine-grained since you have sort of several layers and each layer is protected on its own. I would say that's the most important argument. I
Mm,
mean, the drawback here is that things really become complex because how it's still within your premises. How can you, from your operational system in layer three, do things towards your controllers and PLCs, which you in many cases need to do? So how do you sort of still obeying the rules, but still how can you operate things across layers so they don't
yeah.
do manual things in each layer? So that's sort of the typical paradox between security and flexibility.
Fair.
So if we zoom into that one a little bit, and mostly where we're going to focus today, if where we see most of our customers, I would say we see most of our customers in layer one and layer two, where they have soft PLCs, they have edge AI solutions, they have HMIs, etc., very close to the production line. If we zoom into those layers and step out a little bit, how have things evolved the last couple of years? Looking at, I would say, traditional IoT. If we look at traditional IoT in those layers, back in time and still today, it's very much focused on you buy hardware boxes from individual vendors. You have vendor A, you have vendor B, you mount the PLCs. You can't drop any new software to it really. If you look at the IoT platforms, they are very data only focused. They just collect data from the shop floor and feed it to the cloud. So that leads to a couple of problems. In many cases, quite a lot of manual on-site work. You need to mount physical hardware for each function, blocking agility. If you have a new application you've developed in-house, where can you drop that application? Because there's no general compute. If you have a new edge AI model, where you do drop it. So those kind of IT platforms and physical boxes leads to sort of a dumb edge. It's very hardwired, and you can't really drop new functions to it, and you can't even share hardware. Where we see our customers are going is that in layer one and layer two, they're buying generic compute, they're buying NUCs, they're buying Raspberry Pis, they're buying Jetsons. They mount them close to their machines. They have Linux, they have a container runtime, and rather than hardware-based things, they drop soft PLC, they develop in-house edge AI algorithms that they need to drop on that, which gives you much more agility. You can drop features in the same way as you develop new software. You can automate because it's software, not hardware. Well, the whole thing about edge AI, we see a lot of cameras, and the edge becomes autonomous. In the left side, you're dependent on the cloud. On the right side, you're not dependent on the cloud because the intelligence runs in the lower layers. So this is a very strong trend. We see that you need to be able to run software in layer one and layer two, not just sending data to the cloud. Which then leads to a problem if you combine that requirement with the layers here. So if I need to run my containers in layer 1 and layer 2, if I need to drop my edge AI models there, how can I do that remotely? Because that is kind of blocked by the ISA-95 segments, because you're not allowed to communicate north to south, you're only allowed to communicate south to north. So what we see when we talk to customers today, first of all, it's a lot of manual work. They actually ask people to send logs over email, or they need to go on site with USB sticks to do the new software. So a lot of operational overhead and not very agile, to be honest. So that is sort of a trade-off and a challenge we see today, and what we need to solve. So can we do remote operations, deploy edge AI models, deploy soft PLCs, edge and containers, update them, monitor, and still obey the rules?
Can you talk a little bit about what we have actually seen on the workarounds, for example, with 5G
Yeah,
modems, stuff like that?
exactly. So, I mean, because you need to do automation, you can't do this by hand. So the classical workaround we see is that if you're an IT vendor, you sort of sell your IT hardware box, you mount it in layer 1, and there's a 5G modem, which totally sort of breaks everything. So you have a direct access directly into layer 1. That's, I would say, the most common one. Or even more common, the manual thing. And we
Yeah.
also sometimes you have sort of temporary VPN solutions. So some solutions you see they give the sort of the remote operations a temporary VPN. You know how complex that can be with USB keys, etc. We also see, well, all the way to punching holes in the firewall or those kind of things. So it's really not totally automated or at all.
Thank you.
That served as a background. So what I hopefully gave an introduction to is that at one hand, we need to remotely be able to deploy, update, and monitor software in the lower layers in the Purdue ISA-95 model. But there's a contradiction here because we have firewalls blocking north to south. What we have introduced in the Avassa platform is a flexible proxy mechanism, which Fred is going to demonstrate now. So a little bit on the Avassa architecture. So our central orchestrator, that is the control tower, which you will see the UI, where Fredrik will demonstrate the tasks he's doing remotely across individual OT networks. Then we have the little agent, the edge enforcer, the little E here. The edge enforcer is something that runs on your Linux box wherever you have them. So typically in each layer here, you would see a Linux box with the edge enforcer running in it. So Fredrik.
Thank you very much. So let me do the share. Okay, so this is, oops, wrong setup, wrong slide. This is where we want to be. So this is the demo setup that we have built. So as Stefan said, we have deployed 4 layers of edge enforcers, simulating layer 1 through 4. So in each layer, we have an edge enforcer. Between the layers, we have a dedicated firewall. And that means, and I will demo this shortly, is that you can only go 1 layer up. So you can go from layer 1 to layer 2, but you cannot go from layer 1 to layer 3, for example. And there is no way the edge enforcer down here in layer 1 can actually talk directly all the way to the control tower, which sits up north here somewhere. That means for this to work, we have to initiate traffic going bottom up. And we do that through our proxy functionality. So the edge enforcer down here on layer 1 will initiate a connection to the edge enforcer on layer 2, and that edge enforcer will proxy it. So we're basically daisy chaining the edge enforcers all the way through the layers until we can reach the control tower. So that is the initialization of the network traffic. Once we have established the connection, we actually get the double-ended communication channel, meaning we can actually send control commands to each of the edge enforcers. They can fetch images from the control tower through the proxies, and we can also feed data through this communication channel going all the way from the bottom all the way up. So hopefully that gives you a high-level understanding of the demo setup. And I guess now I'm going to try to prove all of that. So I'm going to start here in the UI, so you can actually see the layers. So each of these are a site. In layer 4, I actually opted for running 2 sites just to prove that we can actually set up multiple sites per level. And the reason you may want to do that is to have a backup. So for example, layer 3 will proxy through layer 4. Actually, all layer 2 and layer 1, 2, and 3 will proxy through layer 4, which means that this is potentially a single point of failure. So therefore, you can actually configure the system to set up multiple points in each layer that we can use as proxy. And I'll show you the configuration for that shortly. To get anything to have something to reason about, I will actually deploy an application. It's nothing fancy. It's an application that consists of 2 images. The first one is basically just logging. It's going to output which layer it's running on. And then I actually have a web server, an Nginx, that will return an HTML page, also just responding with which layer it's running on. So first thing I will do is I will create a deployment for this application and actually run it, because now I'm not running it anywhere. So I'm going to go here. I'm going to call it layer logger. Oops, choose my application. And I'm going to say run it on all sites that have a layer label, which happens to be these 5 sites. So as you can see, the application is deploying, going through the layers here. And if I go back here to my application list, we can see that it's actually up and running. So with that in place, I just briefly want to show you a little bit more. So here we'll actually go into the terminal. So this is the edge enforcer in layer 1 that I'm running. This is the one in layer 2, and finally one of the hosts in the uppermost layer. And the first thing I want to show is, so if I run, for example, up here, so this one actually has access to the control tower, which means I can reach this. So this is the URL of my control tower. We have a health C endpoint there that returns a payload that I just use to check if I can connect. If I do the same thing on one of the other layers, you will actually see that it just stops there. And that is just because of the firewalling. So I can't really reach out anywhere except from the current layer and the layer above. And the way I've configured this is, so each layer, I'm actually running a 192.layer number. So this is 192.168.1. That means this is in layer 1. If I do the same thing here, you can see that this is 192.168.2. So for example, I do expect to be able to connect to the layer 2 one here. So if I do 2.10, I can ping this from the layer 1. If I do the same thing, but trying to go into the 3rd layer, meaning 2 layers above this, I actually don't get any response. But now if I go to the 2nd layer, I do expect to be able to ping 1 layer above, and that is doable. But what is also important here now when I'm in layer 2, I shouldn't be able to reach anything in layer 1. So I'll try to prove that by pinging down. And as you can see here, I actually don't get any responses. So hopefully that proves that we have 4 layers, segmented layers or segmented networks, you can only go up one layer at a time, and you can never go down. The
So
way, if you,
let me ask you, so this shows exactly the rules of that network segmentation, but still you just did the deployment. So there the control tower could send a command to each layer. So all the layers got a command northbound to sort of deploy a new application, and each layer could sort of pull the container from the control tower. So can you explain a
yes.
little bit more how that actually works?
Yes, perfect. That's a good question. So let me try to explain it like this. So if you have seen our installer before, you can see here in the subd.conf, I actually have configured this guy in layer 1 to talk to the edge enforcer in layer 2. And if I do the same thing here, subd.conf, you'll see something similar, but this guy reaches out to the layer above it. So basically, when we establish our communication channel where we get, for example, applications and deployments and images and so forth, this guy never tries to connect all the way to the control tower. It only connects to the edge enforcer in the layer above. And that one in its turn will connect to the next layer. And we keep doing that until we get to, for example, this guy that doesn't have a proxy. If we look at this guy, we can see that this guy doesn't have a parent proxy, which means that it can connect directly to the control tower. So we establish the connection one step at a time. We daisy chaining through the edge enforcers. But once we have that connection established, it becomes a double-ended, which you typically have in a TCP or a UDP session. Once it's established, you can actually send traffic both ways, right? Did that answer?
Yeah, I think also the last thing here, since you established the connection from south to north, but you of course then can go the other way around.
Exactly.
Mm.
But again, this doesn't require any opening of firewalls. It just requires a firewall to keep the session alive.
Great, thank you.
So I'll just demo. I'm going to do 2 demos on the app itself. I just want to prove. So for example, here I can click my layer 1. So here I'm running my application. Now I'm drilling down into the layer 1 site. We can see that the applications are actually up and running. And for example, I can ask for the logs. So I'm going to click here and start query. And what I expect to see here is actually exactly this. So just a log saying I'm running at this layer. So it's just a stupid application that does exactly that. And if I go to a different layer, let's go to layer 3, go to logs, do this, start query. I expect to see logs from saying it's on layer 3. So this is all good and well. We know that the application is running on each layer, but sometimes you actually need to access. You need to do some kind of admin operation down into the layers from a layer above. So that's actually why I put the Nginx here. So we have a feature in the product and in our command line tool that we call the subctl connect in lack of a better word. And what you can actually do is you can go here and ask the system, please generate a command line command for setting up a connection from the laptop or the computer where you're running subctl to a particular site, to a particular application, and you can actually bind the source port on your laptop, and we will actually forward traffic. So this is what I want to show you here. So the way I'll do that is I'm going to do subctl connect. And I'm going to go, so let's say I want to connect to layer 2 here. So this say, go to the layer 2, connect to the Nginx instance that is listening on port 80, and bind a local port 10,000 on my computer. But the idea here is that you can set up a tunnel that you can reach from your laptop and reach all the way down into a particular application. So typically we see like admin UIs that you want to reach in certain cases to do troubleshooting, and this is a tool to enable that when you do it right.
If you ask to, so if I have a central operations team, I have maybe 10 shop floors, each with their ISA-95 networks. With this, I actually can point my web browser to a specific OT network, a specific layer, and say a specific local web UI there, and get it running on my central operations.
Exactly. That is the idea. That is the idea. That actually concludes the demo. So I'm actually gonna give it back to you, Stefan, to conclude the session.
Thank you, Frederick. So hopefully what we presented here is, first of all, a trend where the OT side goes from a pure data forwarding thing more to an intelligent thing where you run workloads in the lower layers. They need to run autonomously, not just feed the cloud, because that's in order to do edge AI, etc. And then it's very important that you adhere to security, that your central security team can carefully set up the network security like Frederick showed, where you have firewalls blocking the communication according to the ISA-95, or should say 99 then. But still you need to enable automation. And with the Avassa proxy feature, you can have your central team set up the security policies, and you can, in a controlled way, still do fully automatic operations of your workloads in the lower layers.
Cool. Would you say that this is for all customers, or are there places where you think this doesn't apply? I mean, all this network segmentation.
Yeah, so I mean, these kind of more advanced things that you showed in your demo, that is typically in industrial environments. In two scenarios, we have customers that are developing machines and they need to drop their machine, let's say in level 1, and they want to do remote management. And for that, they desperately need something, the things that we showed you here, or you're actually operating the shop floor yourself, and then you need it for your internal purposes. If you go to general enterprises, they normally do the flat thing, like you asked initially. They have sort of the private network and the DMZ. In that environment, they still need our proxy, because in that way, it's sort of one layer proxy. You would have one edge enforcer in the DMZ and the other edge enforcers in your private network. So you still need the proxy function we have, but in a single layer.
Just on a side note, are there any limits on how many layers? Have we built this particular for ISA-95, the 4 or 5 layers we have there, or can you do it arbitrarily deep?
That's a good question. So we can do it arbitrarily deep. Also, I mean, if you sort of search the internet for like these layers, you would get different layers. There is sort of no real consensus, although you can go back to the source, but some have 6 layers, some have 3 layers. So our architecture is totally flexible. We can have a single layer for a DMZ, or you can have 7 layers. You can just daisy chain any number of layers as you like.
Okay. Thank you so much for joining, Stefan, and diving deep on this topic.
Thank you, Fredrik, for the demo, and see you next time. We have other Ask the Experts webinar coming up, so keep monitoring our Ask the Expert registration page and some invitations over email.
Thank you.
Thank you. Bye.